Hi everyone, I'm Han Cao. I'm now a master's student in computer science at UCSD. Today I'm going to introduce you how to delete a node from a binary search tree. So first we need to know what a binary search tree is. First, it has to be a binary tree. So for any node of a binary search tree, it has at most 2 child nodes. And also it has 2 constraints. For any node n, the elements in its left subtree are smaller or equal to n, and the elements in its right subtree are all greater than n. Here is a figure. For any given node n, it shows clearly its left subtree and its right subtree. So here is also an example. We can look at for the root node. Here is its left subtree, and here is right subtree. As you can see, all elements in the left subtree are smaller or equal to 4, and all the right subtree are greater than 4. And this also holds for 2 and 6. So basically, for any parent node in the tree, the constraints hold. So if we want to delete a node in such a binary search tree, first we need to find this element, right? And we should use the basic property to search in the binary search tree. For example, if we want to delete 7, we first compare it with the root node 4. 7 is greater than 4, right? So we need to move its right child node. Then we compare it with 6. 7 is still greater than 6, so we move right again. As you can see, we get the 7. It is equal to the element we want to delete, so we finished. And this process is complexity is OH. H is the height of the search tree. Okay, so we need to consider 4 possible cases we may encounter. First, such an element may not exist, right, in this binary search tree. And if we find it, there are 3 possible cases. It may have 1 node child nodes, it may have 1 child node, and it may have 2 child nodes. We may look at these cases one by one. First, if such an element doesn't exist, for example, you want to delete 10 from this binary search tree. After we searched in the tree, we find that, oh, it doesn't exist, then we do nothing, right? And if we want to delete a leaf node, for example, 8, we'll find the 8 in the tree and we find it has no child nodes. In this case, we simply remove it. We do nothing to the rest of the tree. We simply remove it from its parent node, And third, if we want to delete a node that has 1 child node, for example, 5. In this case, it has a right child node 6, right? So in this case, we need a temporary variable to store or point to this node. And then we remove this 5 and we look at its parent node 7. We made the left child node of 7 point to 6. And that's all. As you can see, the constraints still hold and we successfully delete it. And last, the most complicated case, or if we want to delete a node that has 2 child nodes, for example, we want to delete 4. As you can see, it's root node, right? So in this case, we need to find a value to replace the 4. And the value is the minimum value of its right subtree. And in this case, this part. So how should we find the minimum value in the right subtree? Well, we just need to find the leftmost node in the right subtree. That means we need to traverse the right subtree all the way to left until we get a node that has no left child nodes. In this case, this is 5. So 5 is the minimum value in the right subtree, as you can see. And we need to do something similar to the third case. First, we need to replace 4 with the value 5. And in this case, as you can see, 5 also has a right child node. So we need to make the left child of 7 point to 6. And then we remove the 5, the node 5. And as you can see, it is pretty similar to the third case. And after the two operations, the constraints of the binary search tree still hold, and we successfully removed the 4. So that's all for my video. Thank you for listening. Please tell me if you have any questions. Thanks.